Hi guys, this video is an overview of FXGL 0.21, which was released a few days ago. And I also wanted to go through the samples that are in the repository. So they're on GitHub. This is, if you've been following FXGL, then you know that this is the sort of main repo page of the source code on GitHub, and in the samples directory, you'll be able to find small, um, basically small projects or mini projects, so to speak, where each feature is covered to a certain extent, and it's done with a sort of minimalized approach. So the first sample, they're not in any particular order, but I thought that the complexity increases as you go along. So S1 will be the place to start if you're just starting with FXGL. Um, yeah, so basically click on that, and then on the main sort of app file, and this is sort of minimal FXGL application where you just sort of set various properties or settings. You can even remove all of that and it'll still run because of default values. And these are essentially the default values that are shown here, except for possibly intro and menus. Right. Here I've got a local copy of all these samples. So this is essentially a mirror, but they are properly ordered in the IDE. And I think it'll be easier if I do it from here instead. So yeah, I'll go through all these samples, and there are 23 of them. There might be more when you come back to the page because I constantly update them as new features are introduced, so you can use them straight away. So when you, well, obviously first you'll need to get FXGL into your own project, and the quickest way to do that is Maven or Gradle. So one of these dependency management tools should be able to, basically get you the latest version of FXGL. Once you do that, and all the dependencies are correct, you can then essentially just extend game application with your main class and set various properties. So width, height, they're a bit more. So if you click on that, you'll be able to see all these things that you can set. The values that you set are going to be constant values per application run. So essentially, you're specifying values for the system rather than for your game. And then these will not be, you will not be able to change them later because they're supposed to run during sort of throughout the whole application lifecycle. You can obtain a copy of those settings, and then you can query various things like width of the application or height. Although these cannot be changed because these are target values, the actual width of the application can be changed using a menu or simply obtaining a reference to display. We'll cover that later on. So for now, basically just worry about settings and things that you can set. Width and height, these are target values, meaning your ideal output resolution, and these values you sort of use to create your textures and various images, icons, and things like that, which will be scaled automatically if the output resolution is smaller. If it's higher, you can sort of increase the value of scale and it will still sort of be full screen if you wanted to. These are pretty straightforward: title and the version. These appear in the title of the window. So if I run this, you'll be able to see that the window is 800 by 600. The title goes here, and then version is sort of appended to the string of that. Full screen is false, otherwise you'll go full screen mode. Intro, this essentially allows you to add either your own or use default intro, which is something like that. So this is the intro animation, which happens every time you launch the game. That is if you enable that thing. Otherwise, you just set it to false when you're developing because you don't want to see the intro every time you run the game. Menus, you can set it to true. Default menus will be auto-generated. There are two types of menus. Main one, which is this. Oh yeah, you'll also need to select profile. So if I set basic test. So yeah, this is the main menu that was generated from various things that you supplied. For example, the title, and just puts the title in this rectangle. This, in the sort of bottom left corner, you can see the version, which is that. The profile that you just entered. What else? You have new game load and options. You can change output resolution. This will scale everything automatically. Controls. By default, there's only one control, which is key P. And when you press P during the game, it'll save screenshot of the game. Audio, you can change music and sound. These are sort of global across the game. Music is basically all of your MP3 files within the game. Sound is all of your WAV files for short sounds within the game. You can restore all the default settings. In the gameplay, you can change difficulty to easy, medium, hard, and nightmare. Those are sort of default values which you can play with. And then set the appropriate challenge within the game. Once you start the game, you can press escape. And this is very similar to main menu. This is actually the game menu. Slightly different. You cannot start a new game because you are sort of in the game. You can resume the game, you can come back to the game menu. You can save current state. If you haven't overridden, so if you haven't implemented save within the code, this will fail because by default it doesn't know what to save. Options are exactly the same, so gameplay controls, so on and so on. And the extra, you could have credits. These are modifiable, so you can add your own stuff when you're finished with the game, pretty much. Trophies, this is where all the achievements are displayed for a particular game. Achievements are bound, so basically achievements are stored in the profile. Once you change the profile, achievements are cleared, yeah. You can come back to main menu and then you can exit the game. All profiles, when generated, are stored in the directory called profiles, which is going to be generated in the root folder of your sort of deployed game. So when you package your game and run it on the client side, this will be generated automatically within each of these things. So basic test is the one that we created. There will be a user profile file generated, which is, I think it's binary using serializable data from various services like audio service, video service. So basically it stores various settings, and those could be changed during application lifecycle. So if you change it in settings, then save the game. When you load your profile back, everything will be loaded as you would expect. So that is pretty much it for the settings. Show FPS essentially creates an overlay where it shows your rendering speed and processing speed. Processing is pretty much how many frames per second you could potentially achieve, and rendering speed is usually 60 frames because JavaFX sort of throttles down to that rendering speed. and there's really no point in going over. Application mode is when you set developer, some stuff will be displayed to the screen. You could change your logging to all, then everything will be displayed to the screen. Actually, it's debug, yeah. So if you change mode to debug, then every single log statement will be displayed to the screen. This is important when you do, well, essentially debugging, when you want to find something within the game or within the FXGL system. Finally, there is a release. It blocks pretty much all of these output statements, except for ones where you sort of say that this is a fatal error. Only in those cases will it be able to say it won't necessarily crash. It will show a dialog where it'll say something like save log and then email developer, although the functionality isn't there yet because we haven't got any mailing system. Right, so the default is developer because this is what you want most of the time. So this was sample number one. The rest are similar. So initializing game, I'll go in the same order as they're created here. So there's you can initialize the game sort of normally, and there's the easy way and the super easy way, which we'll cover in a second. So each entity in FXGL world, well, it doesn't really have anything. Entity is just an object, and you sort of decorate it with various components. So, for example, here we're creating an entity player. Then we say we're adding new type. The type is player. So now after that line, your player object, your player entity will know its own type, which is useful sometimes when you want to do collision detection or something similar. You can then add position to an entity by adding a position component, which is essentially a pair of x and y coordinates. Then you have rotation component. By default it's 0, so when you create an entity it doesn't have anything. You have to add all those things manually, which can be done in a simpler way, which we'll cover in a second. So graphics is what you use to display your entity as, and we're doing rectangle. Finally, once you're done setting your entity up, you just supply it to the game world. And the one that we see on the screen is player entity. It has its own type. It has position, which is 100 in x direction and 100 in y direction. If you remember, y-axis, unlike in maths, in many graphics frameworks, it goes down, so positive y-axis is going down. Rotation 0, so it's not rotated. If we do something like 30 degrees, this is actually in degrees, so if you specify that, it should rotate, yeah, it rotates clockwise, yeah, 30 degrees. And by default, 0 degrees means it's facing right. It is important for certain projectiles when you add a projectile control so that it's calculating the angle from its velocity, and then it will rotate the object. So if it's not facing right from the start, so if the texture isn't facing right, you might run into some issues. So yeah, that is how you initialize an entity and add it to the game world. Those comments are hopefully helpful if you're reading it using your IDE or whatever. But there is an easier way to do entity initialization, and it is using game entity, which is a subclass of an entity and guarantees to have certain components. like the ones that you would expect typically. Type, position, and view, and also rotation. And instead of adding a component, you simply query the component. So it's slightly easier, I think. You simply get the component, set value, and these are actually hot swappable. So you could run the game, and at one time you can change view, position, type, which is nice because you would want to be able to do these things to game objects. And the resulting application is exactly the same. You'll see a rectangle at 100, 100. There is also easier ways still using entities. This has been introduced only in this version 0.2.1, so this is one of the new additions. There's a static class called entities. You called sort of a class that has a collection of static methods. You call builder, and then you sort of, using Fluent API, you call various things like type, which will assign type to it, at which is the position component. View from node, there's a few more views, so you can generate a view from node only. You can generate it with bounding box, so it will automatically add a bounding box around your entity view generated from your node. You can also generate it from texture. Those things actually will come to assets in a few samples. And finally, you build and attach it to the game world. Or you can just build and then attach it to the game world at some point later. So this is sort of the super easy way, and I would say this is a recommended way because it's just easier to read and less typing. Then we've got input, which is crucial to pretty much any game. So the way to do it is to get input service, which you can do like this, and you essentially add an action. You define a new user action, so this is sort of anonymous class. You give it a name, and this must be unique because it will identify the action. And then during runtime, your users can rebind actions to different keys because yeah, it's just nicer that way. It has three methods that you could override, or these are essentially callbacks. So an action begin is executed when the user is just starting to press the key, so basically first tick. On action is executed as long as the key is held by the user. On action end is executed during the last tick, essentially during the same tick when the user released the key. And if we run this and press F, you'll be able to see the stuff that's going on in the console. So when you just hit F, you get action begin. This is executed during an action, and finally action end is executed, which corresponds to these callbacks. And finally, you supply the key that you want the action to be bound to by default, which is F. It used to be P, but it's now a screenshot key, so I replaced it with using F. This is input sample number 2, which is an alternative way of doing input. So instead of specifying it directly right there, you can add an input mapping, which is essentially a string action name to trigger, which is this. And you specify the actual code somewhere else, and that somewhere else is here. You annotate it with on-user action, and then this name has to be exactly the same as this one, so that input service could map those things together. Then the type, which is exactly like these things: an action begin, an action end. And these are the things that will be executed when you trigger the action, essentially. So that's that. It doesn't really matter which way to use. I think there isn't really a difference, except for where the code is placed. So if you want to do it in one go, that's fine, or you can do it in this way. The signature has to be public, void, and no parameters. This this is how it will identify the user action to be called. This is if you want to do manual check, so don't worry about that for the moment. So you get input anytime, and then you simply call is held, and then you pass in a key or a mouse button, and it will say if the key is pressed or not at that very moment. So currently I'm not pressing the key, so held false. If I press, it'll become true, and when I release, it'll automatically become false. So this allows you to do sort of the old school way, just checking if it's pressed or not. But I would say this is more preferred when you bind an action, because this way users can change that key at runtime. So they can change it in their profiles. Right, physics. This is sort of soft physics, so to speak. This is where you can do collision detection. The well, the input is essentially just doing left, right, up, and down for the player, and we have two entities, player and enemy. In initialize game, we create a player using the Fluent API. Same with enemy, and then we must attach collidable component to each of them with the flag true. This will allow the collision system to see those components or those entities so that it could perform collision detection on them. And the way you do collision detection is essentially in init physics. It doesn't have to be in this method, but it's useful for everyone else later, because they'll be they can easily find where your physics thing happens. You obtain reference to physics world by just calling get physics world, and then you add a collision handler between two types, type player and type enemy. Then you'll need to override a few things like collision begin, collision, and collision end, similarly to action begin, on, and end. These will be fired, and you can also override on a hitbox trigger if you want to know which hitboxes were hit. Currently, we only have one hitbox per entity. So this is the player. If I go closer to the enemy, or rather if I overlap with the enemy, you can see the collision detection, the collision system firing. And then you can perform various things depending on what exactly you want to do. Collision begin is fired during the first tick. On collision is fired constantly as long as the collision is happening. Collision end is fired during the last tick when the collision happened. UI is, so you can mix FXGL objects or FXGL UI objects and native JavaFX objects because of how the game scene handles UI, because it contains a list of nodes essentially, which is rendered in the UI overlay, which happens above the game world, or representation of the game world in the game scene. So you can define your, for example, text, set font as usual, and then translate X and Y, which places the object, And finally, you can do things like binding properties, for example, text property to something like tick property of FXGL. And then you add this. It is very similar to the way you add entities, except the game world, you instead of the game world, you add it to the game scene. So this is our UI object, the text property of which is bound to text property is bound to tick property. So every time new tick happens, it just constantly updates to the current tick. And I think final thing for this video, so the rest of the samples I'll cover in different parts so that the video isn't long. We've pretty much covered menus, so this is how you enable intro, and this is how you enable menus. So if both of them are enabled, they will be executed in order. So this is your intro animation, which you can customize. And this is your menu animation, which you, or not an animation, but menu, sort of main menu, which you can again customize. And select one of these things. So if we select the one from a different sample that we did earlier, basic test, it will say the profile is corrupted because it doesn't match, it couldn't match name of the application and name of the profile for which contains various things about the application. So if we select menu, which is the one for that, I believe, yeah, it will select properly. This is it for this part. There will be a second part covering the rest of the samples, and thanks for watching.